All right, today we are going to talk about min-max word problems. All right, so just a quick reminder, first of all, before we get into this, that the maximum problem would be a value of k where the parabola opens down, because then the vertex would be a maximum. A minimum word problem is one where the parabola would open up, because then the value of k would be a minimum, which is why we call them max-min word problems. So here's an example. I am putting a garden in the backyard. I only have 50 feet of fencing and I want the maximum area. What will be the dimensions? So let's draw a picture. You have a garden. You're going to say this is X. Well, if that's X, then this is a rectangle. This would also be X. So I'm going to set X equal to width. It's critical when you have these write your own word problems that you define your variables, because I called it X, but you could call it A, B, W, whatever you wanted to. The y is always going to be what you are trying to maximize. So in this case, I'm trying to maximize the area of the garden. So I'm going to set y equal to the area. Well, if I take a look at what the perimeter of this garden would be, it would be 50 feet because I have to only have 50 feet of fencing. So if I go across and down and across and back up, it has to be equal to 50 feet. So the perimeter is 50 feet. So how much fencing I have left, or the perimeter that I have left between these two areas, would be 50 minus 2x. But I have two areas that I need to put that, so I have to divide that by 2. So each one of these sides would be 25 minus x. Well, since I set the y equal to the area of the garden, I have to write an equation for the area of this rectangle. Well, the area of a rectangle is length times width. So the area would be x times 25 minus x. Well, now we have our quadratic equation. We can now either put that in our calculator and find the maximum, or we can solve it out by hand and find the maximum. If I multiply this out, I would have minus x squared plus 25x. Using our equation for the vertex, I would say h is negative 25 over 2, or h is 12.5. So now I know that the maximum is 12.5. Well, remember, that's our x value, and we set x equal to the width. So we know our width is 12.5. If we substitute the 12.5 into this 25 minus x, we would then know the length. So we know that it is 25 by 25 feet. Don't forget your units, feet. All right, another example, I am putting the garden against a pre-existing fence. I'm still using 50 feet of fencing. What will be the dimensions of the garden so that the area will be maximized? So now I have a wall here, and I'm going to be putting my garden up against this wall. I'm still going to set my width equal to x and my area equal to y. But now I have my perimeter is really only from across, down, and across, because this is really not included. So 50 minus 2x will be my length, and I do not have to divide that by 2 because my wall is taking up this space. So I'm still going to write my equation for the area, length times width, x times 50 minus 2x. Again, now that I have this, I can solve it. I know what my h value is. H, or again, this I set my maximum to the width, so that's my x value, is 12.5. But now I'm going to substitute that 12.5 into this equation, 50 minus 2x. And I know that the maximum garden I can make if I have 50 feet of fencing and one side up against a wall would be 12.5 feet by 25 feet. Let's try another. I want a garden of maximum area using a 50 feet of fencing, but I want to leave a 2-foot opening on one side so I can get in and out of the garden without crawling over the fence. What will be the dimensions? All right, so here now is my garden. I'm going to leave this 2-foot opening here. All right, so my width is still going to be x. My area is still going to be my y, because that's what I'm trying to maximize. But now my perimeter, if this is my fencing and this is 50 feet here, I still have this 2-foot space here. Even though there's no fencing there, I still need to include it in the perimeter of my rectangle. So my perimeter of my rectangle is 52 feet. So I have 52 minus 2x, but I have to put that in two different places. So my length is actually 26 minus x. I have to take my perimeter, 52 minus 2x, and divide it by 2. Now that I have my length and my width, I can write my equation. Again, put it in my calculator or solve it out by hand, and you would have 13 feet by 13 feet would be the maximum area of my garden, or the dimensions of my garden with a 2-foot opening. Let's take a look now at one of the thrown or dropped equations. A ball is thrown from a height of 4 feet with initial velocity of 60 feet per second. What is the maximum height it would reach? Well, we know that the thrown equation is this right here. Let's plug in what we know. It's thrown from a height of 4 feet, so that'll be our initial height, with initial velocity of 60 feet per second, so that'll be our VO. The units are correct. They're in feet and feet per second. So I substitute these in. Again, I can use my minus b over 2a to figure out what that maximum height would be. And I have a maximum height of 1.875, which is actually the time. That's my h value. So I have to plug that into my equation to get the height. And the height is 60.25 feet. Again, don't forget your units. They are very important. All right, if you have any questions, let me know.